Welcome back, ladies and gentlemen, and welcome to the We Do portion of the problem set, lesson 20, where we're going to convert measurements. And as I want us to really focus on before we start is that you can do this. I know it's sometimes difficult. I would love to be there with you, to sit with you one-on-one to help you. I'd love to be in that small group answering questions. I'd love for you to work with a fellow genius to solve some problems. We can't. So whether you're trying to do these individually and try to be proactive and persevere through this, or you're having a fellow family member or a guardian helping you, okay, know that you can do this. And if you're still struggling after this video, okay, know that we will continue to practice, try to get some Google Meets in the next week or two, okay? All right, so let's get started. We had page 32 is your reference sheet. And our problem set, I have it on page 86. Let's look at letter F, as D is going to be your exit ticket. So that reference sheet is going to be very important for you. If needed, just rewind it to the 1 minute mark and you'll see that reference sheet. So let's solve letter F. Okay? So we have 3 2/3 feet and we're turning it into yards. We do know that there are 3 feet equals 1 yard. Let's move this over a little bit. Equals 1 yard. There we go. So if I was going to draw a picture of 3 feet, I might even put it in just one tape diagram and just label here's a foot, here's a foot, and here's a foot. That's really 1 yard. That's great to know. But now I'm going to do that same thing for our 2/3. Here's our yard, our 1 yard. Here's our feet, our 3 feet. But I don't need a whole foot. Out of this 1 foot here that I'm putting in purple, I only need 2/3 of it. So I'm going to decompose it into thirds. And I really only need 2 of them. So if I'm looking at this, I'm going to have 2 shaded pieces, or needed 2 pieces. What is there going to be our total, our whole thing? Well, they need to be equal pieces. So if you're thinking you have to decompose this one and this part of their model, you are correct. They decompose it. Now, how many equal pieces are there? Well, there's 3, 6, 9. We just said 3 feet is 1 yard, so we have 1 yard and 2/9 of a yard. And there is your answer. And that's model form. If we're doing it in number form, I am going to take my 3 2/3 and I'm going to turn it into a mixed number. Well, let's make that look like 3. There we go. Well, what does this 3 really represent? Well, it really represents 3/3 plus 3/3 plus 3/3. I might even put these in parentheses, showing there's my 3 wholes. And I also have 2/3. How much is this all together? Well, 3, 6, 9. 9 plus 2 is giving us 11/3. And we're going to have 11/3 feet equaling our blank, our missing yards. I'm going to rewrite this as 11/3 times 1 foot. Now here's where we got to stop and think. This 1 foot, and I'll make it in red this time. Again, coming back up to our picture in the other one here, 1 foot. What is that in relation to our yard? And 1 foot is really 1 out of 3 pieces for our yard. It's 1/3 of a yard. So our expression, 11/3 times 1/3 yards. And we know with our little shortcut that we can just multiply right across. 11 times 1 is going to give us 11, and 3 times 3 is going to give us 9. We have 11/9. I can pull out 9/9, and I'm left with 2/9. And as a result, okay, we would have 1 whole and 2/9 left over. And that matches our work right here. Again, to me, it doesn't matter whether you are doing it in picture model form or in the number form. Maybe you do it both to check your work. That would be very proactive of you. Let's check out 1 or 2 more. Now, the next ones aren't in your workbook. You're going to use the left side of your workbook, that blank page, or a scratched piece of paper. Because again, we're focusing on the conversions and not the word problems. The rest of the problem set is word problems. Okay, so I'm going to start by doing this one in pictures. And I have knowing that 1 foot really equals 12 inches. So I'm going to draw a model. And I'm going to represent this as the 1 foot. I'm going to represent this one here, 1 foot. And 1 foot is really 12 inches. I'm going to turn that into 12 inches. Really important to know. Now I need to do 7/8. I'm going to draw a model here. I'm still going to represent this as 1 foot, but I don't really need the whole thing. I really need 7/8 of it. So I'm going to divide this into 8 equal pieces. That means 7 lines. 1, 2, 3, 4, 5, 6, 7. And let's shade it in with the side of our pencil. I'm going to use a highlighter here. And we're going to do 7 of those. Hopefully it shows up here in our picture. Maybe it won't. Oh, there we started. And we need 7 of them. There it is. 7/8. Now, this is our missing piece. I know that this is really 12 inches. We want to work in inches. I want to do 7/8 of the 12 inches. Now, right now, you might be thinking, oh, Mr. Philp, I know what of means. It means multiplying 7/8 times 12. We can write that as 7 times 12 divided by, or a fraction line, divided by 8. Now, you might not be able to solve that in your head. You might be able to simplify it. Right? If not, find the scratch piece of paper, move off to the side a little bit, and let's do 12 times 7. 7 times 2 is 14, so we got to bundle the 1. And 7 times 1 is 7 plus 1 is 8, 84. But we need to divide it by 8. So I'm going to rewrite this and do 84 divided by 8. And remember that the whole number, or 84, goes underneath the house in our standard algorithm. How many 8's going to 8? 1. You used all 8 of them. Bring down the 4, as many of you are so great at doing. How many 8's go into 4? Well, I can't do any of them. 0. Put our 0 here. And you're left with, squeeze it in there, 4. And now we could put this as a decimal and line up the decimals. But since this has been in a fraction form to begin with, we're going to keep this as a fraction and do 4/8. There, 4 divided by 8. There we go. Now, it's a lot of work for this one problem. Okay? Here is part of your answer. This is your shaded part here. But you can't forget that you found 12 inches over here as well. So we have our 12 inches plus our 10 4/8 inches. Putting those together, we have a total of 22 inches and 4/8 of an inch. You might even think of that as a half. There is your answer. A lot of work, but you came up with the correct answer. The same goes with if we do this in number form. We have our 1 7/8. And I'm going to turn that into a fraction. Now 1 whole is going to give us 8/8. And we still have our 7/8 left over. That's giving us a total of 15/8. Now remember, when you add fractions, the denominator doesn't change. Only when we multiply, we use that little shortcut. So now I have 15/8 feet equals so many yards, or excuse me, inches in this case. Inches. How do we solve that? Well, I'm going to take our 15/8 and I'm going to multiply it by 1 foot. Because now I know I can change this 1 foot into inches. We wrote that over here. That's our conversion. I'm going to do 15/8 times 12 inches. There's our conversion, which ultimately brings us to 15 times 12. Our fraction line means divide, and 8. Now, you could simplify that if you can, but most of us might just go ahead and straight multiply. So I'm going to, off to the side, or on another scratch piece of paper if you need to, we're going to do 15 times 12. And I'm going to start with this 2. 2 times 5 is 10, so I have to bundle the 1. 2 times 1 is 2, plus 1 is 3. Now, since I'm done with my 2 in the 1's place, and I'm done with the little 1 here, I'm going to cross them out. And everything that I'm going to do is 10 times as big. So I'm going to put a 0 here. Let's use this 1. 1 times 5 is 5. And 1 times 1 is 1. What do we have to do when we have 2 of our partial products? Add those together. 0, 8, and 1. Okay. So I'm going to now show that I have 180 fraction line, or which means division, 8. Can I do that in my head? Probably not. So off to the side, I'm going to do 180 divided by 8. Let's get a different color here for this one. How many 8s go into 1? 0. We didn't use any of them. So we find the difference of those, and we're left with 1. Bring down the 8. How many 8s go into 18? If you need to, skip count. 8, 16. Oh, let's try 2. 2 times 8 gives us a 16. Difference of those is 2. Bring down the 0. How many 8s go into 20? It's still going to give us that 16, so we're going to do 2. 2 times 8 is 16. We're left with, ooh, squeeze that in there. We're left with 4. Again, we could make it a decimal and bring it down, but since we started in a fraction, we're going to leave it as a fraction. So we still want 4. We still want to divide it by 8. And look at that. There's our answer that we would have to put into our label, and it matches. Again, it doesn't matter to me which one you use. I might suggest at least getting the handle on it. You try both to see which one you feel more comfortable with. Right, now the video, we already have 13 minutes because I give you a couple strategies. Okay. I would like to try to do one more, but I don't want to have the video run too long and lose your attention. So if you're still confused as you're working on the exit ticket, let me know. Okay? I'll reach out and try to help you out as best that I can virtually. Okay? I wish you luck. Thank you for joining us for the We Do portion of Lesson 20 Problem Set.